Hi students, problem number 19 is also based on another application of Gauss law. Two large thin metal plates are parallel and close to each other. On their inner faces, the plates have surface charge densities of opposite signs. That means one plate is negative charge, the other plate is holding positive charge. So minus sigma is the surface charge density of the second plate and plus sigma is the surface charge density of the first plate. So they are having the numerical value of the surface charge density, okay, or the magnitude as 17 into 10 power minus 22 coulomb per meter square. Okay, what is asked here? There are three subdivisions. What is the electric field in the outer region of the first plate? So I will call this as the first plate and this as the second plate. So on the outer surface of the first plate is region 1. Okay. So I can say that this is region 1. And what is the electric field in the outer region of the second plate? So if this is the second plate, on the outer region is right side, okay, outer region number 2. So this I can call it as region 2, which is the right side and outside of the second plate. Third one, what is the electric field in the region between the two plates, So that is region 3. So in region 3, what is the net electric field? This is the question. Now first of all, we have derived one application of Gauss law. If there were a single plate, okay, extending up to infinity, that is very large, then what will be the electric field on either side of the plate? If it is positively charged or negatively charged, the electric field due to a single metal plate we have derived, that is E equal to sigma by 2 epsilon naught. Is it not? And that is positive for positively charged plate and negative for negatively charged plate. Okay students, now you come to the picture. You understand that in the picture there are two metal sheets. So the first one is charged positively and the second one is charged negatively. So I will consider the region 1. So this is the point. So this is the point. At this point A, there will be two electric fields. One due to the positive charges present on the first plate, and that is denoted by E plus. Okay, E plus. And this due to the positive charges, it will be directed away from the metal plate, away from the charged metal sheet. So you can see the direction of E plus towards the left. Understood? At the same point A, there will be another electric field due to the presence of the negatively charged second plate, and its direction will be always towards the charged metal sheet. So this is E minus. E minus is the electric field at this point A, and that is due to the negatively charged metal sheet. Understand? The point A is at different distances from the first plate and the second plate, but still the magnitude of the electric field will be the same, only their directions will be opposite. Because what is the expression for the electric field due to a single metallic plate? So we have already studied. So E is equal to sigma by 2 epsilon naught. This expression does not have the term distance. Is it not? It is independent of the distance. At a closer point or a far off point also, the electric field will be the same. Therefore, the magnitude of E plus and E minus at this point A must be the same. Suppose if it is E plus means here plus sigma by 2 epsilon naught, and E minus means it must be equal to what? Minus sigma divided by 2 epsilon naught. Is it not? E plus and E minus. These are the magnitudes. Okay students, you tell me at this point A, that is at region 1, that is in the outer region of the first plate 1. How many electric fields are there? There are 2 electric fields. Their magnitudes are equal, but the directions are opposite, is it not? So I can also express this in vector form. Okay, so the resultant electric field E in the region 1. First I will take this region 1 at this point A, that is in the region 1. E is equal to E plus vector plus E minus vector. So this is equal to sigma by 2 epsilon naught minus sigma by 2 epsilon naught. So the electric field, net electric field at this region 1 is equal to 0. Have you understood this first of all? Yes, on the outer region of the first plate, that is on the left side of the first plate, the resultant or the net electric field due to these 2 plates will be equal to 0. There is no electric field on the left hand side of the 2 plates. Okay, now let us take the region 2. Easy to understand, similar to that of the first region only. So I call this point as B. So at this point also there will be 2 electric fields, one due to the positive plate and the other one is due to the negative plate. Always the electric field due to the positive charge will be radiated outwards. So the direction of E plus, must be towards the right side, outwards, that is outward from this plate. So B is on the right side of the plate 1. Therefore the direction of E plus is towards the right. Whereas this same point B, there is another electric field E due to the negative charge. And by sign convention, this field E minus at the point B should be directed towards the negatively charged plate. Is it not? So here also you can observe that both these E plus and E minus are having the same magnitude but opposite directions. So they will cancel each other. So in the region 2, the net electric field E2 is equal to E plus, okay, vector minus E minus vector. So if you take the signs, means it is a sigma by 2 epsilon naught plus minus of sigma by 2 epsilon naught. So this is equal to 0. Therefore E net in the region 2, that is the outer region of the second plate, also is equal to 0. Have you all understood? Okay. What is the third region? Third region is, it is the region between the 2 plates. So I will take another point C. So this is the point C. Okay. Here also how many electric fields should be there? There are 2 charged plates. There must be 2 electric fields. Okay. At this point C, the electric field due to the positive charge is directed towards the right hand side. And you see at the same point C, the electric field E minus due to the second plate must be towards the charged plate, and that is also towards the right hand side, that is towards the right side. Is it not? So both E plus as well as E minus, they are acting in the same direction and they have the same magnitude. Understood? They have the same magnitude and the same direction. So this time you can take that this will be equal to what? So the third region is you see that E3 okay is equal to E plus okay vector, E plus vector plus E minus vector. Now since both are in the same direction, their magnitudes only will be added. This plus and minus sign we need not utilize here because their magnitudes only are getting added up. Therefore I will write this is equal to sigma by 2 epsilon naught okay plus sigma by 2 epsilon naught. So 2 sigma, so this is 2 sigma by 2 epsilon naught. So this must be equal to sigma by epsilon naught. Therefore the net electric field in the third region is equal to, okay, its magnitude is equal to sigma divided by epsilon naught. So here also you can see it is independent of the distance. Anywhere, at any point, anywhere between the two plates, the electric field is a constant. It is a uniform field. So the electric field is uniform. This is the term we have to use. That is why we use such an arrangement in the construction of a parallel plate capacitor. Understand? So my dear students, in this arrangement of two infinitely large charged metal sheets, there is no electric field on the outer regions of the first plate as well as the second plate. And certainly there will be an electric field at any point in the region between the two plates only. Okay students, now this is the net electric field's magnitude that is asked here. So what is the electric field in the region between the two plates by substituting the values of sigma and epsilon naught. So already the value of sigma is given here. Therefore, I am going to write here, I am going to continue here. Therefore, E3 is equal to sigma by epsilon naught. So in place of sigma, I will substitute 17 into 10 to the power of minus 22. And that is divided by epsilon naught. Epsilon naught is 8.854 into 10 power minus 12. Okay, I am going to use the calculator now. Okay. So 17 into 10 power minus 2. 17 divided by. So first I will write as 17 divided by 8.85. Okay, this is coming as 1.92. 1.92. 10 powers is here minus 22, here minus 12. The remaining is minus 10. So into 10 power minus 10 Newton per Coulomb. So this is an application of Gauss law. So you must remember this formula thoroughly. Understand? Due to a single charged metal sheet means the electric field at any point irrespective of the distance from the plate is what? E is equal to sigma by 2 epsilon naught. So there is no electric field on the outer regions of the two plates, and the inner region between the two plates only there will be a net electric field. Okay students, I hope you must have understood this well, fine.